Hello everyone! In this video, you will learn about the definition of absolute value function and how to determine if the given relation defines an absolute value function.
Suppose there are two athletes running. We have athlete A and athlete B. The two athletes started running on the same point. Athlete A runs to the east, while athlete B runs to the west. Let's put the two athletes in the Cartesian plane. The point where the two athletes started running is what we call the origin. Suppose after 30 minutes, athlete A already covered 5 kilometers, and athlete B covered 6 kilometers. Observe the direction and the distance covered by the two athletes. In the x-axis, athlete A covered 5 units going to the right,
while athlete B covered 6 units going to the left. Since athlete B is going thirds to the left, therefore it is negative.
Take note that there's no such thing as negative distance. Therefore, that's where absolute value comes. The distance covered by athlete A is represented as the absolute value of 5, which is equal to 5. Also, the distance covered by athlete B is represented by the absolute value of negative 6, which is equal to 6. This is an example of using absolute value in real life.
From that scenario, let us now define what an absolute value is. So the absolute value of a number is the distance between that number and 0 on the number line. The absolute value of x, written as the absolute value of x, represents the distance from 0 to x. Take a look with this illustration. The number line represents the distance from 0 to negative x, which can be expressed as the absolute value of negative x, which is equal to x. Also on the right side, the distance from 0 to x can be written as the absolute value of x, which is also equal to x. As we observe further, a sign of a number inside the absolute value tells us the direction as well as the distance of that number from the origin. Since the absolute value represents a distance, therefore, it is always positive or equal to 0. For example, the absolute value of negative 5 is equal to 5. The absolute value of 9 is equal to 9. And the absolute value of negative 50 is equal to 50. It's easy, right? Well, just use the positive value of the number. A good way to remember this is when you are dealing with absolute value, remember to stay positive. Now that we know what an absolute value is, let's look at the absolute value function. An absolute value function is a function that contains algebraic expressions within absolute value symbols. The parent function can be written as f of x is equal to the absolute value of x. This is the simplest type of absolute value function. All the absolute value functions stem from the parent function. The parent function is defined as a piecewise function. F of x is equal to x given that x is greater than 0. F of x is equal to 0 given that x is equal to 0. And f of x is equal to negative x given that x is less than 0. So if we're going to graph this piecewise function, the graph will consist of two rays. This ray and this ray. As you can see, the graph is a V-shaped graph that opens upward. The corner point of the graph is called the vertex. Notice to the left of x is equal to 0. This line is given by the line y is equal to negative x. Also on the right side of x is equal to 0, this ray is given by the line y is equal to x. Now, the last question of this video is how can we identify if a given relation defines an absolute value function? To identify whether a given relation defines an absolute value function, for example, given the Euler equation, let's recall the definition of an absolute value function from earlier. So an absolute value function is a function that contains algebraic expression within absolute value symbols. So from this definition, we can simply tell if a given Euler equation defines an absolute value function. So if the given Euler equation has an algebraic expression within absolute value symbol, therefore it is an absolute value function. Also, The general form or general rule of an absolute value function takes the form f of x is equal to a times the absolute value of bx plus c plus d, where a, c, and d are real numbers. Or in some other references, they use the form f of x is equal to a times the absolute value of x minus h plus k. But in this video, we're going to use this form. Now, let's have some examples. Identify whether the given rule defines an absolute value function. If not, explain why. So for example number 1, we have f of x is equal to negative 7 times the absolute value of x minus 6 minus 5. So observe the form of the equation. As we can see, it takes the general form of an absolute value function. F of x is equal to a times the absolute value of bx plus c plus d. Therefore, this example is an absolute value function. Example number 2. h of x is equal to the absolute value of x plus 1. Let's compare the two equations. Are they similar? Some might say not, because example number 2 does not take the general form. But observe the symbols used from the two equations. Yes, aside from taking the general form, the presence of absolute value symbols tell us that it is also an absolute value function. Therefore, example number 2 is an absolute value function. For example number 3, we have g of x is equal to the square root of the absolute value of x plus 0.75. As mentioned earlier, to identify whether a given rule or equation defines an absolute value function, it should take the general form, or it should have the absolute value symbol. So, does g of x take the general form? Obviously not. Does it have absolute value symbol? Obviously yes. But does g of x define an absolute value function? For those who answered yes, sorry, but you have to try again. Yes, g of x contain a very evident absolute value symbol. But take note that the function g of x also contain a radical sign. Recall the other type of function. Remember the type of function who has a radical sign as one of its characteristics? Yes, we have the square root or radical function. Also observe that the absolute value is inside the radical sign. Therefore, this is not an absolute value function, but a radical function. Let's try the next one. q of x is equal to x squared minus 5x plus 4. What can you say about the equation? By just merely looking at the equation, we can simply tell that this equation is not an absolute value function. Observe the highest degree exponent of the equation. The highest degree exponent of the equation is 2. Since the highest degree exponent of the equation is 2, therefore, it is a quadratic function. Now, let's answer the last example. With the last example, we have f of x is equal to x minus 7, given that x is less than 0. F of x is equal to the absolute value of x plus 13, given that x is greater than or equal to 1. And f of x is equal to x squared plus 9, given that x is greater than 3 but less than 5. Interesting, right? Some might wonder if it is possible to combine different type of functions in just one equation. Yes, as you can see, it's possible. Now, if this equation defines an absolute value function, take note that this function contains different types of functions, namely linear, absolute value function, and a quadratic function. Yes, the absolute value function was mentioned, but there are other two types of functions. Remember what type of function is this now? Recall how the current function was defined from earlier. Take note also that the function has its own set of intervals. Remember now? Yes, it is a piecewise function since it is a function that contains multiple subfunctions, and each subfunction has its own set of intervals, or what we call domain. Overall, To identify whether a given rule or equation defines an absolute value function, first, it should take the general form and it should have absolute value symbol. But you have to take note if there are other type of symbol in the given function. How about if the given relation is in terms of graph? How can we identify if a given graph defines an absolute value function? For us to identify whether the given graph defines an absolute value function, we should bear in mind that the graph of the parent function defined as a piecewise function from earlier is a V-shaped graph. Therefore, we can simply tell if the given graph defines an absolute value function if it is a V-shaped graph that opens either upward or downward. Let's try some examples. For the first example, we have letter A. Let us try first run a vertical line test. There is only one intersection on the graph, therefore it is a function. Obviously, it is a V-shaped graph, therefore it is an absolute value function. It's easy, right? How about letter B? Does it define an absolute value function since it is a V-shaped graph that opens to the right? Let us try first run a vertical line test. Observe how many intersections do we have. We have 1, 2 intersections. Yes, it is a V-shaped graph, but it failed the vertical line test. Therefore, it is only an absolute value or just a mere relation. Let's try to answer the last example. As we can see, if we try to run a vertical line test, it will intersect the graph at exactly one point at any part of the graph. It passed the vertical line test, and it is a V-shaped graph that opens downward. Therefore, it is an absolute value function. It's simple, right? Overall, the graph of an absolute value function is a V-shaped graph that opens only upward or downward. That's it for our video tutorial about the definition of an absolute value function and how to determine if the given relation defines an absolute value function. I hope everyone enjoyed and learned something in our video. In our next video, we will be discussing about finding the domain and range of an absolute value function. So if you have questions, suggestions, or clarifications, please don't hesitate to comment below. See ya!